For our third example, we have simplify sine of 2 theta all divided by 4 cosine of theta sine of theta. So again, the question becomes, how do I know when to use a double angle formula? Well, this one actually is pretty obvious. I mean, you have a sine of 2 theta, and right there inside of the parentheses is a 2 theta, right? So you're probably going to use a double angle formula. And furthermore, as I said, that's the one you really need to remember. Sine of 2 theta equals 2 sine of theta cosine of theta. You can easily see that once this gets replaced, we're going to have some things canceling on, wrong example, sorry. We're going to have some things canceling on the top and bottom of this fraction. So that's why it's important to remember. Sine of 2 theta equals 2 sine of theta cosine of theta. Because we can simply see that when this is replaced with 2 sine cosine, there's a bunch of stuff that's going to cancel. So this is a very simple example. Step 1, we're going to simplify the trig expression, basically using any method we've learned before up into double angle formulas. You can't simplify anything here. I know students might say, oh, this cancels to become 2. No, the 2 theta is inside the parentheses. There's a theta in these parentheses. You can't just do that. Those are two separate expressions, and this is basically what I tell kids all the time is this is basically like a brick wall. You can't mess with it. When you have these variables inside of trig functions and they're different in any way, namely theta and 2 theta, you just cannot cancel those out. So step 1 is complete. I mean, we can't do quotient identity. Everything's already in terms of sine and cosine. We can't use Pythagorean. Nothing's being squared. So we're going to move on to the next step. Step 2 is to write the trig expression in terms of one trig function. I'm going to say if possible. However, we really can't do that here. I mean, we can't really change sine in terms of cosine, right? Using any identity I know of, unless they're being squared. And we're really left with one option, which is to use double or half angle formulas, and that's step 3. So that's exactly what we're going to do. We're going to move on to step 3. Step 3 says to write the expression in terms of double or half angle. We're going to use that exact identity. I told you that's the number one double angle formula you need to memorize, which is that sine of 2 theta is equal to 2 sine theta cosine theta. So there's two ways to do this. I could change this right here to 2 sine theta cosine theta, and it's going to work out the same way. The way I worked this one out was a little bit different, kind of in reverse. So what I did was I took this 4 and I changed it to 2 times 2. So now I have a 2 cosine theta, 2 sine theta. Next, I basically flipped these around to put sine and cosine first, and now we have indeed 2 sine cosine the theta, which is equal to, again, going back to our double angle formulas, that's equal to sine of 2 theta. So I'm just going to replace that with sine of 2 theta. Again, you could do it the other way. You're going to get the same thing. If you change the top, I decided to change the bottom. However, there is still a 2 before that we need to pull down. So that original 2 is going to come all the way down here. And now we have sine 2 theta over 2 sine 2 theta. Well, now what's inside of those parentheses is exactly the same. So we can indeed cross the top out with the bottom. So basically what's going to happen when we cross these out, that will leave me with a 1 on top and a 2 on bottom. The final answer then is simply 1/2. We started with something looking complicated, sine of 2 theta over 4 cosine theta sine theta, and we end up with a simple 1/2. That's it for this example of using double and half angle formulas to simplify trig expressions. If you have any other questions about this, let me know.